All right, so starting second semester, we're going to talk about rules of logarithms again. I know this is a little bit of review. All right, and for all of these problems, okay, I'm just giving you tools to be able to solve these problems. However you want to solve it is completely up to you. All right, so as we talked about before, all right, when we have two numbers multiplied together, or maybe it's a number and a variable, it doesn't really matter, or maybe two variables, you can split them apart by adding them. Okay, so this is the same thing as we had before. We might have had it in reverse order, but you guys know, due to our properties, that we can switch things around and it's not a big deal. Same thing over here. If we have two things that are divided together, we can split them apart by subtracting them. Okay, the big thing with that is these base numbers here, these b's here, have to be exactly the same. Okay, now for this first one, I'm going to show you two different ways to do it. I'm going to show you the way that I would do it first, which is not how they want us to do it here, but then I'm going to show you how to use this actual property here to be able to solve this. So we've got log 2 of 16, and we'll say it equals x. All right, now for this one, okay, technically you could throw that in the calculator and get an answer that way. Say it's on the no calc test that we'll have in a couple weeks. And you want to, I'm just going to ask you to solve for x there. All right, so how I would do it is I would throw this into exponential form, and I would go 2 to the x equals 16. All right, and I would do it that way because I know that 2 to the 4th equals 16, so x has to equal 4 here. All right, so that's personally how I would do this one, but say that you absolutely wanted to use this property. That's okay, we can do that. All right, what are two numbers multiplied together that gives us 16 here? 4 and 4, that's probably the easiest one. So what we can do there is, instead of having the 16, we can have 4 times 4. So this would be a log 2 of 4 plus log 2 of 4. Okay, and then how this first one works here is this would be like saying 2 to the x power equals 4. Well, 2 to the 2nd equals 4. So this would be a 2. The second one, we do the exact same thing. 2 to the x equals 4. So our x value would also be a 2. 2 plus 2 is also 4. Okay, so same answer for both. Doesn't matter which way you do it. All right, so any questions with using our product rule there? Okay, for the second one, there's different ways to do this one too. I probably wouldn't use this division one for this one either, because this fraction, can we simplify this fraction first? What does this become? Not x to the 4th, x to the 9th. Remember, when we have a fraction, we have exponents here, as long as the bases are the same, we can subtract our exponents. This becomes x to the 9th. This 9 comes out in front, so we'd have 9 log x of x. All right, and whenever these two are the same, this is always a 1. It doesn't matter if they're variables, if they're numbers, whatever the case is. This turns into a 1, so this is just 9 times 1 equals 9. Okay, that's how I would do this problem. Say you want to do the quotient rule here. All right, we've already got our two terms here. So this would be log x of x to the 12th minus log x of x cubed. And then we just have to simplify each one of these. So this 12 comes out in front. This thing turns into a 1. 12 times 1 would just be a 12 then. Same thing for the 3. We pull the 3 out in front here. This log x of x turns into a 1. So 12 minus 3 is 9. And we got the same answer for both of them. Okay? As you guys know, I don't care which way you solve a problem, okay? Just get it solved, however you need to. All right. There's the first lesson. Any questions? That is legitimately the most that I can pull out of that lesson to be able to teach you. So that's it for lesson 49. Do you guys need a break or should we go to lesson 50? You need a break already? I don't think so. Lesson 50 is all of 3 slides. So I'll torture you through this lesson, and then we can go from there. And then the interesting thing about this semester is we are going to have some lessons where it's just a one-page lesson. Even as long as Mr. Quislin's lessons are, he's not going to be able to pull much more than 1 slide out of some of these lessons because they're just that short. That is true. I mean, he might be able to pull 4 slides, but I don't know how he'd get 20 or whatever his average is. So go ahead and copy this down. We'll talk trig equations really quick here too. All right, now the biggest difference that you will see in this lesson compared to what we've done in the past is seeing our restrictions here. Our answers, we need to give all of the answers that fall between 0 and 360. Okay, and that's what you'll see more of this semester, that there'll be restrictions here a lot of the times. This will be the restriction, but you got to pay attention to it because they will kind of mess around with them a little bit. Sometimes it'll be x is greater than or equal to 0 and just less than 360. Okay, so just be careful with what the restrictions are. Make sure you read them all. But we're going to have to pay attention to those as we go here. All right, so for this one, your first step here is simply we need to solve for x. So we got to move the cotangent over to the other side. When we do that, we can't divide trig functions. Instead, we take the inverse of them, okay? And I'm just going to leave it as 1 over the square root of 3. You guys know we should try and get rid of this square root of 3, but it doesn't really help us any to be able to do that, okay? Now, the one thing this is what I do when I solve these problems. I know that cotangent works with tangent, and tangent is opposite over adjacent. So for this problem, we're not dealing with tangent, we're dealing with cotangent. So this would be the reciprocal of that. So it'd be adjacent over the opposite. And then we just need to draw our triangle here. Okay, which quadrant are we going to be in where both the adjacent side and the opposite side are both going to be positive? Yep, that's going to be in the first quadrant. So we're up here. Opposite side is square root of 3. Adjacent side is 1. What is our reference angle going to be here? 60. Yep, it's opposite our square root of 3. So we've got a 60-degree angle there. So that's our first answer. It falls in between 0 and 360. So that's one of our answers. All right, now remember, there are always, when our x value, when the number out in front of x is a 1, there are always going to be 2 answers in between 0 and 360 degrees. Okay, and so where is the other triangle going to be at where we have this ratio after it's simplified? Yeah, it's going to be down in 3. Now, one way to remember that is for tangent and cotangent, they always just flip into the opposite quadrant. All right, and what happens here, instead of being a positive square root of 3 for our opposite side, it's going to be a negative square root of 3. Our adjacent side, instead of being a positive 1, is going to be a negative 1. And then when we write that fraction, those negatives just cancel out. And that's why that works then. All right, so For this, reference angle still stays the same. What angle do we get starting at the positive x-axis going all the way around to where we end at here? What would that be? 240. And that's in between our 0 and 360 also. So there's our two answers. All right. Any questions at all? All right, let's go to the next one. Now notice, first of all, that we do have a little bit more complicated equation. It's okay, we're gonna do the exact same thing as we did on the last slide. And our restrictions changed here. And because those restrictions change, sometimes we'll still have two answers. Sometimes we could have one, sometimes we could have 0. It kind of depends on what the problem actually is there. All right, so with our equation, just like a normal equation, we got to get x all by itself. So what are we doing first? What do you think? To get x by itself, we got to move the 2 over first, right? So we subtract the 2 over. And then we're going to have to divide by the square root of 3. So we've got cosecant of x equals -2 over the square root of 3. And then we got to move our cosecant over. So x equals cosecant inverse of -2 over the square root of 3. All right, and now we're ready to draw our triangles again. Okay, cosecant works with sine. So sine is opposite over hypotenuse. So cosecant is going to have to be hypotenuse over the opposite side. All right, now first question would be, well, our hypotenuse can't be negative. What are we going to do with that negative sign then? Yeah, we just put it to the bottom, okay? So we're going to get rid of this one, and we're just going to move it to the bottom. So when we graph this, where is one quadrant going to be where our opposite side is negative? Opposite is always going to be talking about up and down. 3 and 4, right? Okay, let's deal with 4 first here. All right, so we've got a negative square root of 3 here. We've got a 2 there. That would mean our adjacent side is +1. What's our reference angle for this one then? Yeah, opposite our square root of 3 is 60. Okay, and that's all we need for this, going from positive x-axis all the way around. That would give us a 300-degree angle, wouldn't it? Is there a problem with that answer though? Yeah, what's wrong with it? Yeah, it doesn't fall in our restrictions here, right? So this is not going to be one of our answers. Okay, and that's okay. We just ignore it. All right, then we got to go deal with the other one. All right, and we probably could have just ignored it because it says it's got to be between 90 and 270. So 90 and 270 are going to be these two quadrants here. All right, so everything over here stays the same except our adjacent side becomes a -1. All right, so then going from positive x-axis all the way around would give us an answer of just 240 degrees. Okay, so based on the restrictions there, that's why we only have one answer. It's going to happen sometimes. I think a lot of the times in today's homework, you're going to get 2 answers, but just pay attention to what the restrictions are because those will change. All right, questions at all? All right. Go ahead, copy it down. Back to normal restrictions of 0 to 360. All right, Chase, what I need here is I need a number 1 through 10. Okay, and then give me another number 1 through 10. Okay, all right. What that means is, Mary, you got to give me the first step here, just the first step to solving this. Yep, subtract that over to the other side. There you go. So 3 cosecant of x equals -3 square roots of 2. Mary, give me two numbers between 1 and 10. What? 1 and 8? That'd be the kid behind you. All right, Kylie, what's the next step? Divide by 3. So we're dividing by 3 here. We end up with cosecant of x equals, now from here, it depends on whether you want to cancel these 3's out or not. I would, just to make it a little bit simpler. So we get negative square root of 2. Kylie, who's going to give me the next step? 4 and what? 6. Connor, you're up. What's the next step? Yeah, just got to move the cosecant over. Connor, who's going next? Between 1 and 10. Huh? 2 and 4, Stetson, you're up. Make our triangle. All right, well, cosecant works with what two sides? It works with sine. Sine is what over what? Good. Hypotenuse over the opposite. Now, we don't have a denominator here. You can always just make it over 1. Okay. All right, Stetson, who's next? 5 and 7. Chase, you're up. What quadrant is this going to go into? So it says here the hypotenuse is a negative. Can we have that? No, so we're going to put our negative down here in the bottom. So where is our opposite side going to be a -1? 3 and 4, very good. So we've got -1 and square root of 2 and -1 and square root of 2. All right, Chase, who's next?
37.
What? 3 and 7. That means Miss Fryer. What's our reference angle for these two triangles? Yeah, it'd be a 45 for each one of them. Okay, if you don't recognize this one, okay, you could always do Pythagorean theorem to get this side. This is going to be a 1. This is going to be a -1. Since our opposite side and our adjacent side are the same length, then this is going to be an isosceles triangle, which means this has to be a 45-degree angle. All right, Tina, who's next? Give me two numbers. Say that again. All right, Cassandra, what are our last two numbers, or what are our answers here? 225 and 315. There you go. And there are the steps. Those two fall within our restrictions. So these would be our two answers. Okay. So there it is. As complicated as it's going to get today. We'll add some stuff to this as we go with this semester, but that's pretty much it. Okay. So follow your algebraic steps. That's really all we did. And then the only thing that we added outside of algebra was we had to draw these triangles to be able to get our two our two answers here. Okay, so homework for today is lesson 49 and lesson 50. Any 25 questions you want. Once again, I don't care what you pick. Make sure that you challenge yourself a little bit with them, okay? But you will have a quiz on, you guys are on Monday, on lesson 50, okay? All right, I have put all that stuff in Schoology for you, so the reminder is there. Plus, I'm pretty sure I put your first test in there too on Schoology, so you'll see those reminders start to pop up. The first test won't be for a couple of weeks yet, but just so that you are aware, and then I'll get you those lesson numbers out soon enough. Just like normal, even though this is a new class, we're still going to have stuff from first semester in here. Okay, so just be aware of that. All right, so as far as Saxon classes goes, this is the same as every other year you guys have taken math here. All right, it's just called a different class now. All right, so any questions for me? All right, you guys can get rolling then on homework. And I gave you a ton of time today to